it's Mariana and we're back with this week's IM2 video. We're going to be going over Unit 5, Section 2 and Section 3 Pre Test Self-Assessment. So let's go ahead and get into it. First thing, or like the first question that we're going to be getting into is this little question, or these two questions right here. So firstly, let's look at what we're asked to do. So it says, using the table above, graph triangle x prime, y prime, z prime, and describe the transformations performed on triangle xyz. So firstly, what in the world? Alrighty, so first thing I want to do is I'm going to go ahead and plot the coordinates and the points of point x, y, and z. So if I look right here, I can see that x lies at 5 on the x-axis. Oh, that was a really bad line. Yeah, 5 on the x-axis and 6 on the y. So we know its coordinates are going to be, 5, 6. Okay, 5, 6, right? Because coordinates are x, y. Then we see that z is at 2, 1. I'm gonna write that down. 2, 1. And y is at 10, 1. Great. Now, what we see here is that it's asking us to flip the placement of the x and y values and then make that y value negative. So what that literally means is that if you can see here, this is our x value. It's gonna, this is our x value and it's gonna go in place of the y value. So really they're just asking us to flip these little guys around. So the 5 is gonna go right here where the y value usually goes, and then our old y value is going to be our new x value, right? Going to move that over there, and then we have to negate this and make it negative and become negative 6, 5, and I'm just going to repeat that with the rest of the points. So that y value goes in front, it becomes negative, the x value goes in place of the y, that y value, this is our y value right here, becomes negative, and we put our x value right here. Now these are our new points. So I'm going to go ahead and plot these just so you guys can visually see what it looks like. Alrighty, so now I have just plotted that right onto the graph. And before I even explain to you guys this, let's take a look at the way this triangle was transformed. So I don't know if you guys noticed this, but do you see how right here, right, when we're at triangle XYZ, x is 6 away from the x-axis, when we're 5 away from the y, right? So if you guys look over here, I can't really rotate this, but if you guys look, if you tilt it, this can become our new x and this can become our new y, and we are still 6 away from this quote-unquote x-axis and 5 away from this y-axis. You can't tell, but I'm making air quotes. Personally, for me, memorizing these formulas that I'm about to give you didn't really work, but maybe it will work for you. But if you guys want to visualize it, if that helps you more, what I would always do is I would turn my paper to where this would become my new y and this would become my new x, so as if you were looking at it sideways, and then I would just plot the distances from each one, right? So if I'm 5 away from the y here, I'd also be 5 away from the y here. If I'm 6 away, I'm right here, 6 away from the x right here, I'd also be 6 away, if that makes sense. But yeah, now that is important when we get to this question right here that says describe the transformations performed on triangle XYZ. So before we even start, I'm going to go ahead and give you a list of formulas that I think could be pretty helpful. I'm just going to put in this little box right here. Okay guys, so I literally just wrote down the formulas, I guess not the formulas, but the coordinate transformation that if this works best for you, you could literally just memorize it. I don't know if you notice here, we were given negative y, x, and that corresponds with this 90-degree rotation, this one right here, counterclockwise. So firstly, I could literally just write here, it's that simple. If you memorize it, so all we literally have to write is a 90-degree rotation counterclockwise. Remember, this is super, super important, because how do we know which way are we going? Are we going clockwise or are we going counterclockwise? That's super important. This is also super crucial. Around 0, 0, wait, Okay, yes, it was around the origin. Now, the reason I emphasize this is because, okay, if we look right here, you see how we are diagonal 2 and up 1? Let's say we were to rotate my paper. So, for example, I don't know if you guys know or like are able to visualize what I mean exactly by that, but I'm going to try to draw it out in hopes that it'll make a little bit more sense. Alrighty, so here's my little drawing, and I hope it makes a little bit of sense. So what I'm literally going to do is, let's say I'm given a problem and it says rotate the triangle 90 degrees counterclockwise. What I would literally do, like I kid you not, this would be me mid-test. I wish I was joking. I would rotate it this way, right? Because if I want my triangle to end up on this side right here, I'd have to rotate it. My paper, I'd have to physically rotate it that way. Oh, sorry guys, I'm out of breath. Where are we? Okay, yeah. So I would literally like rotate that way. And then I'd be like, okay, now this is my new Y, this is my new X. So how far was it from my old X and how far was it from my old Y? And I would just plot everything that way.
This is literally just like the first question, but I also do notice that no numbers here are plotted, so I'm going to go ahead and plot that. Alrighty guys, so these numbers are plotted. I'm going to go ahead and see where every point is at. I can see that point A is at -2, 6. -2, right? Because 2 is our X, where we're at on our X-axis, and the Y is where we're at on our Y-axis. Now, I can see that B is also -2, but this one is at -2, -2. And then C is at -4, -2. Perfect. So we have our base like coordinates down. Now I can see right here that it's telling us for each of our X and Y values, we're going to multiply them by 1/2. Now you could probably do this in your head, but we're going to write these out just because I feel like it's helpful to visualize what we're actually doing. So let's say we're just going to move down here for now. What I'm literally doing is I'm just doing 1/2 times -2, comma 1/2 times 6. Okay, and from here, I don't know if you guys know this, but multiplying by 1/2 is the same thing as dividing by 2. Those are the exact same things, right? Because if we do 1/2 times 6, that is literally just saying 1/2 times 6/1, which simplifies down to 6 divided by 2, which is 3. So this new Y value is 3, and this new X value is 1. So I'm just going to plot that down. And I'm literally just going to repeat these steps with the rest of the coordinates. So -2 times 1/2, that's -1. That's also -1. And then -4, that's -2. And that's -1. Yeah. So now I'm going to go ahead and plot all these points. Okay, I'm wondering if any of you guys caught my mistakes, because I'm realizing just how many mistakes there were. Firstly, these are supposed to be positive numbers, so I changed those to positive numbers. And then, guys, why did nobody tell me that this is +4, -2? I'm here putting negatives. I'm so sorry. These are unnecessary negatives that we did not need. That should literally just be 2, -1. Okay. Let me finish plotting. I'm so sorry, guys, if you had written that down. Apologies. Okay. Oh my goodness, I love how this makes straight lines. Okay, so now that we plotted that with our new points, our last question that we're asked is describe the transformations performed on triangle ABC. So what this is literally saying is, from this bigger triangle, how did we get to A prime, B prime, C prime? Now, I don't know if you guys can notice, but this is literally just like a mini triangle inside our original triangle, right? And if we're stretched, or like if we're stretched in or out, right, if we're dilated, then if it's stretched bigger or smaller, that's known as a dilation, right? We can have a vertical dilation, which is like a horizontal stretch. A vertical stretch, or we can have a horizontal dilation, which is a horizontal stretch. Now, right here, we can literally tell, we don't even have to, well, firstly, from here, we can tell that there's a dilation. There's a dilation by a factor of 1/2, right? Because each one of our values are multiplied by 1/2. But if you didn't, if you weren't given that, we can literally just tell that by the graph. If you can see here, our point is at 4, -2, right? If we cut both those values in half, we get 2, -1. We literally just cut every single point in half. I don't know if you guys saw that. -2 became -1. -2 became -1 again. 6 became 3. and -2 became -1. So we had, I'm just going to go ahead and write a dilation by a factor of 1/2. That's literally all you have to write, because that is really the only change that happened. Everything else stayed the same. We simply just made it smaller. Like, we literally just kind of shrunk it, and that's known as a dilation. Alrighty, guys, let's move on to the next question. Home stretch, so we are almost there. These are the next 2 questions we're going to be going over. Anyways, so this question here, it says, identify a series of transformations that would map triangle ABC onto FED. Now, first, before we even start, I want to go ahead and look at which angles correspond to which angle. That I feel like is super crucial and very, very helpful. So if we have triangle ABC, right, ABC, I can actually notice that A corresponds with point D, so I'm just going to go ahead and write that down. And then I also see that B and E correspond with one another, so I'm just going to write E. And lastly, last value is F. Now, obviously, you could have also written this FDE and CBA, as long as what really matters is the angles in the middle. Okay, now that we've established that, we're trying to figure out how we can map this triangle right here onto this one. Now, my first thinking is that we want to go ahead, we want to get the points on top of one another if we can. So my first thinking is I'm going to try to get point A onto point D. And the way we're going to do that is, I don't know if you guys can see this, but point A is 1, 2, 1, 2, 3 away. Does that make sense? So we are down 2 from D, and we are to the right 3. So to get from A to D, we'd have to go up 1, 2 units, and then go to the left 1, 2, 3 units. So that's going to be my first transformation. I'm literally going to write, AB, what in the world? ABC up 2 units. Wait, that's a lie, guys. Left 3 units and up 2 units. Right? That's going to be my very first transformation. I'm actually going to write that a lot smaller. I don't know why that is so big. Okay, guys, I actually forgot the most crucial step. Translate. This word, guys, if you don't have this word on there, nothing counts, right? You have to translate triangle ABC left 3 units and up 2 units. Translations is literally what this whole unit is about, right? Translations, dilations, things like that. Well, transformations. I don't know if you guys know this, but transformations is the umbrella term. That's a really bad umbrella. And everything fits inside it. It's dilations, translations, things of that sort. Yeah, so it's a translation of triangle ABC, left 3 units and up 2 units. So I went ahead and plotted that, and that's what this looks like. Now, I want you guys hopefully to notice that if we were to literally rotate this entire guy, we could have it land right on top of it. But how are we going to do that? We're going to rotate. So I'm going to go ahead and erase this part. Okay, I'm going to select, hopefully just this triangle. Oh my, no thank you. Okay, hopefully I selected just that triangle. Now, okay, let's pretend that point A prime and D stay right there, right? Let's pretend it's stuck there. If we were to rotate it along that point, we would literally get right there. Do you see how if we just were to rotate it 90 degrees, we'd end up right on top of that point? That is what I want you guys to notice. So literally all I'm gonna write are the next transformation that I need to get triangle ABC onto triangle FED or DEF is to rotate 90 degrees. Remember, counterclockwise. The direction is super important. Around. Now, this is also very important. We have to talk about what we're rotating around. Now, if you guys saw, I struggled a little bit just because it's like I couldn't have these two parts stay connected, but if that had been connected, when I would rotate it, it would have translated onto it, right? And so this point right here that I was emphasizing, if it's stuck, is -1, 0. So what we would need to do to translate it is to translate it, what we need to do to rotate it is to rotate it 90 degrees counterclockwise around -1, 0. Right? Because if prime A and D were to stay right there and we just like rotated this guy around, we'd be able to map it onto this one. And that's really it. Yeah. Once again, you could try the strategy that, I had. If that works for you, it really depends. Whatever works best, guys. Okay, guys, let's go on to our last question. Wait, there's actually something here I need to fix. Okay, guys, last question. We can do this. Okay, so last question is telling us to justify the congruence of the two triangles by describing transformations that will map one triangle onto another. So what we want to emphasize is that we want to get like segment TU on KL, right? Because they're supposedly congruent and we're trying to prove that. And segment SU to KN. Here's how we're going to do that. So firstly, I am going to go ahead, we are going to go ahead and translate this along this little segment right here, right? And if we were to do that, I'm actually going to draw a little triangle so I can show you guys. Okay, so let's literally imagine we're going to translate along that line, pretend it's still there. You see how we end up right here? Can you see how S prime and M aren't perfectly yet mapped onto one another? So what that means is after I translate, I'm going to rotate up until, pretend it stayed right there. Okay, I'm going to rotate up until M and S prime are literally just touching. That's my goal. So remember how we were literally right here? Yeah, I want to rotate until they are touching. And then after that, can you guys see how we would be able to map this triangle onto here? All we would have to do is like reflect it like a mirror. And that, like, all it is, imagine this is a piece of paper. If we just folded it over, bam, you'd prove the congruency, right? Because this angle is, this segment is right on top of this segment would be right on top of this segment, and obviously these are like touching. If literally we would just have to like fold it over like a mirror. So all we're gonna write down is exactly what I just said. Everything that I said verbally, we're just gonna write this down into words. So let me go ahead and get my pencil out. So what we did firstly is that we translated along directed aligned segment TL, and I don't know if you guys know this, but if there's a line segment, it has to have this little line on top of the two letters, right? This was the line that we translated on, and then we still had to rotate, so we rotated until point S, well, S prime, right? Because we had translated it, so we moved it once. S prime maps onto M. And then after that, we just, well, I couldn't like physically show you guys, but we would have reflected over LM. Yep, that's how we would have ended up reflecting it. Now that we have that done, it's just time for us to write a congruency statement, but lucky for us, we kind of went over that earlier. So if we are to say, the funny thing with the congruency statements, as long as the two angles correspond to one another in that same order, you're fine. So like literally, if we know that T and L correspond with one another, if we know that point T and L correspond with one another, we can just write T and L as the first ones, and then we know the next one that corresponds is S and M, so S, M, and lastly we can just write U and K. So K and U. TSU or UST or KML or LMK, as long as the order of the angles corresponds with each other. Alrighty guys, that is it for today's video. If you guys still have any lingering questions that you're curious about or things that you want to review, feel free to request tutoring from Mu Alpha Theta. But that's it for today's video, and we'll see you guys next week.